Hi folks, today I'm going to walk you through the derivation of a parabola that opens downward. Okay, let's say we have a parabola that opens down. It's going to be kind of a rough sketch. Now remember, two items that work together that create the parabola is your focal point and the directrix. So let's say my vertex right here, this is going to be HK. All right. Now, the distance from a vertex to a focal point, remember, was p units. From the vertex perpendicular to the directrix was p units as well. So using that distance, we know that the focal point should have a coordinate of h, k minus p. All right. We know that if I would add p to go up, that the equation of the directrix would be y equals k plus p. Now, what we're going to go ahead and do is choose just some random point on the graph. Let's go ahead and say maybe a point right here. This is going to be my x, y coordinate. Well, I'm going to go ahead and connect it to my focal point. I'm going to connect that perpendicular to my directrix. And we know from the definition of a parabola that this length should equal this length. Let's go ahead and say this is distance 1. Let's say this is distance 2. Now, using all this information, what I'm hoping to end up with, my final statement, will be the standard form of a parabola that opens down. You'll recognize it is negative 4p y minus k is equal to x minus h squared. I don't know why that made that red. It's h. Okay, there we go. So that should be my final statement based on my information. Now, before we begin this proof, one thing that is really useful to kind of speed things up is being able to square a binomial. So remember our little rhyme. If we have something such as a plus b squared, you're more than welcome to expand it using FOIL, the distributive property, but I think it's much faster and more time efficient if you were to do this. Okay, remember, first term is the left one, the second term is the right one. So square the left, square the right, double the middle. This means to multiply the two together, and then you double that, plus 2ab. You square the left, you square the right, you double the middle, the answer's in sight. Okay, so now let's take a look at our distances. We know that these two distances should be congruent to each other. They should be equal. So let's find the distance from the point xy to my focal point. Remember, this is my x and this is my y in that coordinate. So the second distance would be the square root. And remember, you're already accustomed to this formula. It's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So here you're just going to use your values provided. So you're going to have x minus h squared plus y2 minus y1. So that would be y minus k minus p squared. So that would represent the distance from the point xy to the focal point. Now the first distance, this is just a vertical distance. So all I need to do is take the larger y value, the k plus p, and go ahead and subtract y. So this distance right here will simply be k plus p minus y. Okay, k plus p minus y. Very, very simple and very straightforward. So what I'm going to go ahead and do in order to prove this, we're going to start by setting these two distances equal to one another. So distance 1 equals distance 2. So k plus p minus y is going to equal this radical, x minus h squared, plus y minus k minus p squared. Now hopefully this statement I'm going to be able to turn into this guy right here. Well, you'll notice the first thing, there are no radicals in the equation. So I need to go ahead and get rid of this first. So I'm going to go ahead and square both sides. Okay. Now the right side, that's going to be easy to deal with. When you square a square root, the radical just disappears. Remember, they're inverses of each other. Now, just to make this a little easier, instead of multiplying this trinomial times itself, what I'm going to do, let's pretend that k plus p is one term. So instead of a trinomial, this is a binomial. This would be the left term, this would be the right term. Okay, so follow along. We square the left, so that would be k plus p squared. We square the right, plus y squared. Now we double the middle. That means I multiply the two together, so negative y times k plus p, and we multiply that by 2. So minus 2y times k plus p. See, doing it this way, all I have to do now is expand this once more and distribute. And then that k plus p minus y squared is completely taken care of. Now, if you want to, like I said, expand the whole thing at once, please feel free to do so. So this equals, we already talked previously that the radical will disappear, x minus h squared plus y minus k minus p squared. Okay, now you'll notice I'm going to go ahead and continue to expand everything except this portion, because that is something that I already need in my final statement. It's part of my equation. So I'm not going to touch that. I'm going to leave him exactly as is. The rest, I'm going to go ahead and continue to expand. So this is the left, this is the right. So square the left, k squared, square the right, double the middle, plus 2kp, plus my y squared. Now we'll distribute minus 2yk minus 2yp equals the x minus h squared that I'm not going to touch. Now, what we just did a moment ago right here, we're going to go ahead and do to this guy. Here's the left term, here's the right term. The only difference is the k minus p is already grouped for me. So I'm going to say, this may take a little more than one line, and that's okay. Square the left plus y squared, square the right, so plus k minus p squared, now double the middle. So I'm going to multiply y times negative k minus p, and then we're doubling that. So negative 2y times k minus p. Now you'll notice there's already one term that we could go ahead and cancel out. It's the y squareds. If I choose a y squared and subtract it over, they're going to become opposites. So that's one less term I have to deal with. Now while these remaining terms here are going to stay the same, k squared plus p squared plus 2kp minus 2yk minus 2yp is equal to x minus h squared. I'm going to go ahead and expand these one last time. And I'm actually very close to being done. So let's see here. K plus p squared. Again, here's the left, here's the right. So this would be plus k squared plus p squared minus 2kp. And now I'm going to distribute. So that would be minus 2yk. And this would be plus 2yp. The two negatives will give you a positive. Now at this point, you're going to notice several other terms that should be able to cancel. We have the k squareds. We have the p squareds. Okay, what else can cancel? We also have negative 2yk. Those cancel. Now you'll notice we have a 2kp on each side, but here this one's positive, this one's negative. So if I take one and move it to the other side, they will not become opposites. They are going to end up combining. So what I'm going to do is take these two terms right here, and I'm going to move them to the left. So I'm going to add 2kp to the left, and I'm going to subtract 2yp from the left as well. Okay, so maybe since I'm doing this on video, I'm going to say plus 2kp. I'll go ahead and write out what I'm doing. Minus 2yp. So over here, I'm going to have plus 2kp, and here I'm going to have minus 2yp. Okay, so that those will now cancel, just so everybody's able to follow along. So I'm going to go ahead and put this negative term first. Negative 2yp minus 2yp would be negative 4yp plus 2kp plus 2kp is 4kp equals. Now the only thing left on the right side is the x minus h squared. Take a look at what we've done so far. It expanded very large for a few steps, but now it's looking very, very much like what I need it to. There's just one last step. Look at the binomial on your left. Do you notice anything that we can do here? Both has a 4 and both has a P. We could say that 4P is a GCF. We can factor it out. Now, because I went ahead and put the negative in front, we're going to pull the negative out with it. So if I pull out a negative 4P, that would leave me Y minus K, which is equal to X minus H squared. And that is the equation, the standard form equation of a parabola that opens down. Okay, now here's what your assignment is. I want you to go back and diagram a parabola that opens up, and I want you to derive or prove that equation. This is due before you leave today, and it is going to be for a grade. Okay, so here's what I mean. You're now going to take a parabola that opens up. Here's the focal point. Here's the directrix. Okay. Here's the vertex at HK. So using the fact that from the focal point to a vertex is P units, from the vertex to a directrix is P units, you're going to come up with some coordinate for your focal point. You're going to connect it to some random point, XY, on your parabola, and then you're going to connect that down to your directrix just like I did. Let's say this is distance 1, this is distance 2. You're going to work your proof the exact same way. There will be key differences because this one is opening up while the one I showed you is opening down. So you're going to say distance 1 equals distance 2, and you're going to go very similar to what we did in this process here. Okay, you can do this. I believe in you. I know that you can do this. You ultimately should end up with this. Okay, 4P times Y minus K is equal to X minus H squared. That should be the final statement of your proof. Okay, now even if you have trouble, work with somebody, get some help, but you have to turn something in. This is due before you leave today. Thank you very much, guys. I will see you soon. Have a great day.